The mechanical events of the contractions of the heart follow the electrical events that are traced by the electrocardiogram. Systole refers to the time period during which a chamber of the heart is contracting and generating force, and diastole refers to the time period when that chamber is relaxing and pressure is decreasing. These mechanical events affect the muscles of the chambers as well as the valves that separate those chambers from each other. The movement of blood from one chamber to another and through the valves is caused by pressure gradients, with blood moving from an area of higher pressure towards areas of lower pressure. The pressure difference on either side of the valve determines if the valve is going to be open or closed, and how that affects blood flow through that valve. During diastole, there is very little pressure in the ventricle of the heart. Because there's so little pressure, blood flows through the atria and through the open atrioventricular valve and starts to fill the ventricles. Following the P wave that's traced on an electrocardiogram, the depolarization of the atria start to contract, generating a small amount of force. That small amount of force finishes filling the ventricles. Following the QRS complex, the ventricles start to contract during their period called systole. During this time, the atria are in diastole. Rising pressure within the ventricle pushes up on the bottom side of the atrioventricular valve and slams it shut. But the ventricles continue to contract. Even though they're contracting, the AV valve is closed and the semilunar valve is closed, so no blood is being pushed out of this chamber just yet. Because of that, this time period is called isovolumic contraction. The ventricles are contracting, but no blood is moving just yet. However, as those ventricles continue to contract, the pressure within the ventricle continues to increase. Once the pressure in the ventricle is higher than the pressure on the other side of the semilunar valve, the semilunar valves are forced open and blood starts to get ejected out of the ventricles, into the aorta and into the pulmonary trunk. Following the T wave, that is, the repolarization of the ventricles start to relax. As they relax, the pressure within the ventricle starts to drop rapidly. That means that the blood in the next major blood vessels, like the aorta and the pulmonary trunk, is actually higher than pressure within the ventricles at this time period. That blood presses back down against the semilunar valves and slams them shut. Because blood's not coming down into the ventricle and no blood's being pushed out of the ventricle, during this time of relaxation, we have an isovolumic kind of relaxation. Because the ventricle continues to relax, pressure within the ventricle continues to drop. Once it drops low enough, that blood in the atria pressing against the atrioventricular valve can force that valve open, then blood will start to refill the ventricle and the cycle starts to repeat over again. The lubbed-up sound that we usually associate with the heart beating is caused by the closing of these valves, the atrioventricular as well as the semilunar valves. The lub sound, the first sound, is the closing of the AV valves that separates the atria from the ventricles, while the dup sound is the closing of the semilunar valves that separate the ventricles from the major blood vessels they serve, like the aorta and the pulmonary trunk. Because the valves on the left side of the heart close just before the valves on the right side, it is possible to distinguish the sounds of all four valves. We do that by moving a stethoscope around to 4 specific points to help limit the sound from the other valves and try to isolate the sound coming from each of the 4 valves at different times.